Today we will show you about the working of digital Theodolite, and to start working with Theodolite we will firstly fix the digital Theodolite on this tripod using this holder, and like this we will do it. Now digital Theodolite is properly fixed over the tripod. Now the very first step to start working with the Theodolite is to center this tube bubble over here. So we will firstly place the Theodolite like this so that the display is in parallel to these foot screws, and we will move these foot screws inward and outward to bring the bubble in center. The bubble is in center, but we will now check it whether it is in center for all side or not. For that we will move the Theodolite 90 degrees, and now we will see whether the bubble is in center or not. It is not in center, so we will use this third screw to bring it into center. Now we will bring it to the previous place again to check whether it is in center or not, and repeating the same procedure to bring it into center by using these foot screws. In the same way we will check it 2-3 times. Now bubble is in center at both sides. So we will check it whether it is in third place, it is in center or not. It is in center at all place. So now we can start working with the digital Theodolite. Firstly, I will tell you about the functions and these buttons of Theodolite. The first button that it is the power button that is used to turn on and turn on off the digital Theodolite. The second button is shift button. It is used for display illumination, and it is also used to turn on the laser plummet. If you will hold it pressed for 3 seconds, the laser plummet will be turned on. The third button is for hold button, and it is used to hold the horizontal angle. After pressing this button, the horizontal angle will not change. To reverse it, just press the hold button again. The next button is V percentage button, and it is used to check the vertical slope in percentage. If we press this button, the display will start showing the angle in percentage grade. The fifth button is zero set button, and it is used to make the horizontal angle of the Theodolite to 0 at any place. This can be done by pressing the zero set button twice. The next button is R/L button, and it is used to change the phase of third light. It is used in transverse surveying. If we press now currently it is showing horizontal angle at R, right side. If we press this button R and oblique L, it will now show in R left side face. If we press this hold button twice, now the horizontal angle is not changing, and by pressing it again, it starts showing the change in horizontal angle. After that we have this slow motion knob. If we want to lock the third light at any place, we will just rotate it to make it lock. Now this third light telescope will not move because it is locked. To slowly move this, we will use this knob, so the telescope will slowly move. And this knob is used in the same way for horizontal angle. If we rotate it and lock it, the third light will not rotate horizontal wise. And for slow motion movement, we will use again this knob to slowly move angle. You can see the angle is changing very slowly. Now after this I will show you about how to measure horizontal. Now I will tell you about how to measure horizontal angle using digital third light. For this we have placed two target prism rods there to measure the angle between these two rods. So for this, firstly we will target our third light, focus it on the first target. We will make firstly the vertical angle to 0, so that we can accurately measure the angle, horizontal angle. Now our telescope is at 90 degree and it is parallel to the surface. So we will target on the first ranging rod, and then we will press 0 set button twice. You can see now horizontal angle is now showing 0. Now after this we will target the second rod to measure horizontal angle between these two rods. Now you can see after targeting the second ranging rod, we can see that the now angle showing is 14 degree 41 minutes and 24 seconds. So this is the angle between first target and second target, like this in this page. This angle we have measured to be 14 degree 41 minute and 24 second. In the same way, we can measure n number of angles between various targets, and it is very easy to measure angles between two targets. Now we will see how we will now check how to measure vertical angle using digital theodolite. The vertical angle will also be measured in the same way, just by using the theodolite telescope. Firstly, I have placed that their ranging rod. Let's take example. I want to measure the angle between the bottom point of the ranging rod to the top of the ranging rod. So I will first focus on the bottom of the ranging rod. After focusing on the bottom of the ranging rod, the vertical angle I am getting is 97 degree 3 minute and 6 second. Now I will target on the top of the ranging rod. And after focusing on the top of the ranging rod, I am getting 87 degree 49 minute and 9 second. So now we will subtract the first angle that we measure at the bottom with the top angle. The angle we have got after subtracting the bottom angle we have got with the top of the angle of ranging rod. After subtracting, we have got 9 degrees 13 minute and 45 second. This is the angle between these 2 points of ranging rod. Now in the same way we can measure vertical angle between 2 points, any 2 points, using the digital theodolite. Now we have ended up measuring horizontal and vertical angle using digital theodolite. We can also mark the point at which the theodolite was established. If we press this shift button for 2-3 seconds, the laser plummet will turn on, and now we can get the laser point at the ground. We have got this point, that center of the theodolite. Now we can mark this with any peg, wooden peg, that from this point we have measured the vertical and horizontal angles. Now we will measure distance using the digital theodolite. For suppose we want to measure distance between 2 points. So for that we have placed a leveling staffs over there. So we want to measure distance from the center of this theodolite to the leveling staff. For that first we will make this vertical angle to 90. Now we will focus on the leveling staff. Now I will show you the reading. You can check there is upper stadia line and bottom stadia line. So we will note down the reading of upper stadia line and bottom stadia line. The reading what we have got is for lower stadia line we have got 1.479, and for upper stadia line we have got 1.64 meter. So we have noted down the upper stadia line and lower stadia line reading. Now we will subtract upper stadia line reading from the we will subtract lower stadia line from the upper stadia line reading. Now we will subtract 1.640 minus 1.479. We have got 0.161 meter reading, and now we will multiply this reading 0.161 into 100. We will multiply it by 100. Now what we have got is 16.1 meter, and this is the distance from the theodolite to the leveling staff. Now we have in this way measured the distance from the theodolite to the leveling staff. In this way we can measure distance to any point, like if we are surveying in a construction place, we want to measure distance between the building and the theodolite, we can easily measure. So now that's all for measuring the distance between the 2 points. Now we will measure the height of any object using digital theodolite. Here for example we have placed that leveling staff over there, and now we want to measure the height of this leveling staff. For this firstly we will make the theodolite vertical angle to 90 degree, and we will measure the reading. We have got the reading of 1.542 meter. After this we will move the telescope to the top of the leveling staff to measure the vertical angle. The angle we have got is 87 degree 30 minutes and 52 seconds. Now we will convert this minutes and seconds to degree by dividing 52 with 3600 3600 and 30 by divided by 60. After dividing 52 by 360 3600, we have got 52 by 3600.0144, and this is we have converted seconds to degree, and these are 30 minutes. We will divide it by 60. We have got 0.5 degree. Now we will add both of these, and we have got 87.5144 degree. Complete. We have converted these minutes and seconds to degree, so we have got 87.5144 degree. Now we will subtract it with 90 angle, so we have got 2.4856 degrees. This is the angle of difference between the horizontal and top of the leveling staff. Now to measure the height of any object, the formula is height is equals to distance multiplied by angle 10 to 2.4856. Distance we have already measured to be 16.1 meter. So, and we have converted 10 2.4856 degree. We have got 0.043409. This you can done by using calculator. By multiplying 16.1 into the value of 10, we have got 0.69888. This is the height from the point we have measured the reading of leveling staff by making the telescope horizontal. Now we will read the reading of staff when it is at horizontal 90 degree. The reading we have noticed is 1.542 meter. Now we will add. Now this is the height we have measured using angle, and 1.542 is the height we have measured using the leveling staff. By adding both of these height, we have got 2.42088. This is the total height of leveling staff from top to the bottom. Now that's all for how to use and measure angles, horizontal angle, vertical angle, and how to measure distance and how to measure height using a digital theodolite of any object.